Okay. Good afternoon, ladies and gentlemen. Oscar, are you there? Can you hear me well?
Yes, sir. Yes.
Very good. If you can hear me well, then we can start our class, guys. I hope you are enjoying online learning, online education. I don't know. The only thing that I worry is about our eyes. Every time, just keep looking at the screen. That's not so good. But anyway, every day we need to try to do some walking exercise and just keep looking at some trees and green stuff. In this way, I think our eyes can have some rest. Guys, we were talking about integration. Today, we will talk about indefinite integrals and the substitution method. In our next session, we're going to have two sessions, and each one is about 30 or 35 minutes, and substitution and area between curves. Okay. And this week, I will finish this chapter. And if we cannot finish today, then I will just make a short video and finish this. Okay, next week we will talk about chapter 6. It's about application of integrals because that's quite a little bit bigger chapter. And tomorrow I know that you have state exams. That means that we are not going to have class. All right. So what will we do? So Saturday I will see. Okay, either we can have class or I'll just record a video and share with you. And next week also you are going to have one quiz. Okay, quiz date I will announce you later, but quiz will be one of your scheduled times, either Monday or Wednesday or Thursday or Friday. Okay, and if I say maybe Monday, it is too close. Okay, but it most probably it may be on Wednesday. Okay, so the quiz again, there will be like 10 questions. You have to answer 10 questions and the online, and some questions you need to choose, some questions you just need to write your answer. So indefinite integrals and the substitution methods. Yesterday we talked about the fundamental theorem of calculus, and by this theorem now we know the relationship between the derivative and the integral, right? So after this, now we will focus on techniques, because differentiating a function, it is quite easy, not so complicated, but integrating a function, it is not that easy, because when integrating a function means that what function's derivative is that function. I mean, answering this question is, most of the time you will see that it requires some skills, okay, and also experience. So now we will talk about one of the methods that's called substitution methods. All right, and that's also one important method in integration calculus or integral calculus. Let's start with this. What is substitution? We are just going to introduce second variable. We call this in math auxiliary variable. Okay, and after that we are going to simplify our integrand function into a simpler form. So if you look at this example, for example, let's say our integral here is, writing. All right, so now it's working. Okay, let me use purple again, my favorite color. Suppose that this integral is I. And if you notice here, if you just differentiate this function, right, it gives us this function. Okay, so now suppose that let me introduce this variable. U is equal to x cubed plus x, right? Now from here, what is du? What is the differential of u? That is d, right? That's the differential of this function, which is equal to 3x squared plus 1 times dx. So that means that, as see here, instead of this 3x squared plus 1 dx, I can just write u. So now at the time our integral becomes here x cubed plus x, that is u, and to the power of 5. And here we have, instead of 3x squared plus 1 dx, I can just write here du. What is it? We just have a polynomial function of degree 5, right? And after we calculate this, I can resubstitute the original, actually this x cubed plus x into y, because our original function is x. Also, you need to leave your final answer in x. That's not enough. So if you continue here, what is it? That's u to the power of 6 over 6 plus c. So now dot, 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 the answer is, what is it? That is 1 over 6. U is x cubed plus x to the power of 6 plus c. So that means that if you differentiate this function, we will get this f of x. Another example, find the integral. Okay, here we have integral. Our f of function is here f of x is equal to square root of 2x plus 1. Okay, so now again here under the square root, because anyway, so let me just introduce this variable. U is equal to 2x plus 1. At that time, our function f becomes f of u equals, what is it, square root of u, right? And since from here u is equal to 2x plus 1, what is the differential of u? The differential of u, that means that the differential of u is equal to f prime of x dx, which is equal to 2 times dx. So now instead of dx, right, from here I can write 1 over 2 du, divide both sides by 2. I can write 1 over 2 du. So now suppose our integral is I, that's the first step. Now the second step is, then I will be equal to integral square root of u times, and not times actually, just dx. Instead of dx, I can write 1 over 2 dx. And 1 over 2 is a constant number. I can just take it to the outside the integral. And integral, here we have u to the power of 1 over 2 du, which is equal to 1 over 2 u to the power of 1 over 2 plus 1. That is 3 over 2 and over 3 over 2 plus c. Or if you simplify this, 2 goes up, right? Here we have 1 over 3 and times, what is u? U is 2x plus 1 to the power of 3 over 2 plus c. Okay, so that is how we calculate, because we call this substitution, because we are introducing new variable, right? And after that, we are just changing the form of the integral, which takes on simpler form in integrating this. Again, after that, we resubstitute the expression that we have labeled by u and the answer. So in general, what are we doing here? So if u is a function of x, g of x, is a differentiable function whose range is an interval I, and f is continuous on I, then the derivative, the integral of f of g of x, g prime of x, that's equal to f of u du, right? Why, as you see here, from here, a differential, this one, g prime of x dx. What is it? It's just the differential of g, right? So that is d g of x. And how did it define differential of x? If you remember, if y is equal to f of x, differential of y is defined as f prime of x times dx. So now using this one, the integral, it becomes f of g of x. And here we have, instead of g prime of x dx, we can write d g of x. So now if you introduce new variable here, let's say u is g of x, right? And here at the time, f of g of x becomes f of u. So then is equal to f of u, and here we have du. That's what we are doing here. Another example, find the integral. Let's say I is equal to secant square root of 5t plus 1. Okay. So if you remember one thing, one identity before we continue this, as you know that 1 plus tangent squared of u, let's say, that's equal to secant squared of u, right? So see here, instead of secant squared of u, I can write 1 plus tangent squared of u. And also, if you remember, what is the, what is it, let's say, tangent of x. Let me just write here, tangent of x. What is the derivative of tangent of x with respect to x? What is it? It is secant square root of x, right? And the dx. Because derivative of tangent of x is equal to secant square root of x. Okay. So now actually combining these two things, if I introduce this new variable, let's say u is equal to 5t plus 1. At the time, du will be, what is it? The derivative of 5t plus 1 with respect to t, that's equal to 5. And here we have dt. So that means that instead of dt, I can write 1 over 5 du is equal to dt. Okay. So using this, let's continue here. Integral and the second square of u, instead of dt, I can write 1 over 5 du, which is equal to 1 over 5 integral. And what is second square root of x dx? That's just d, right? Derivative of, actually, and I should not write here dx. We have already dx on the right hand side. So second square root of x dx, right? I can write d tangent of x. So here we have d tangent of u, right? So now tangent of u is just our independent variable here. So which is equal to 1 over 5. And here we have tangent of u plus c. And dot, 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 the integral will be, what is it? 1 over 5 tangent. And our u is 5t plus 1. And here we have c. Okay, let's move on. These are just simple concepts. So find the integral cosine of 5 theta minus 3. Again, here, immediately, let's say this I, our variable will be u, that's equal to 5 theta minus 3. Then differential of u will be, what is it, 5 times d theta, or d theta is equal to 1 over 5 du, right? So now, using this formula here, we have integral cosine 5 theta minus 3, that's equal to u. And instead of d theta, I can write 1 over 5. Let me just keep 1 over 5 outside. And here we have du, right? So that's equal to what function's derivative is cosine of u? We know that's just sine function. That's 1 over 5. And here we have sine of u plus c. So dot, dot, dot. The answer of this integral will be, what is it? 1 over 5. And here we have sine. What is u? U is 5 theta minus 3. So here we have 5 theta minus 3 plus c. Askara, is everything okay?
Yes, sir.
Good. All right. Another example, because here, we are just working on a method, a technique. To improve your technique or technique of integration, you need to practice more and more different problems. Of course, you don't have to practice the same questions or similar questions, different problems. So that's why actually deliberately here, different questions were selected here, and to give you some idea about this method. But sometimes some questions you will see that it requires more skill actually to be able to handle those integrals. Anyway, here let's say integral equals this. Again, if I just write this I as integral, and here we have sine of x cubed, right? And times here we have x squared dx, right? So now as you see here, if I just introduce this u is equal to x cubed, and what is the differential of u? That's equal to differential of x cubed, which is equal to 3x squared dx. Or here we have x squared dx, right? So I can just write here then x squared dx is equal to 1 over 3 du. Okay, so now then our integral becomes integral equals, this indefinite integral equals 1 over 3. Again, you know that I just keep this outside. Here we have 1 over 3 integral, and sine of x cubed, that is sine of u, and x squared dx, that's equal to, what is it, 1 over 3 du. 1 over 3 is outside. Here we have just du. That is equal to 1 over 3. And what function derivative is sine of u? That is minus cosine of u, right? So that's equal to minus cosine of u plus c. Dot, dot, dot. The answer of this integral is minus 1 over 3 cosine of, what is it, x cubed. Or it is just x cubed. I don't have to put parentheses here. So here we have x cubed plus c. And this is how we integrate this with substitution. Evaluate the integral. Here we have integral x times 4x plus 3 dx. Guys, here we have 8 examples, okay, 8, and that's it. And after this, we have some break and do the last part of this chapter. Evaluate the integral. Now from here, x, right, 4x plus 3, and what can we do here? If you just bring this x inside, it will be x squared. So Askar, what do you think? How can we solve this problem? I mean, how do we integrate this function? Our function here is f of x is equal to x times square root of 4x plus 3.
Let us equal let x is u and 4x plus 3 is v, and then we need to derive and find by uv and then put it in an integral. Is that right or no?
Good. We can do like this, right? For example, let's say u is equal to square root of 4x plus 3. Okay, so at the time, if you square both sides, here we have u squared will be 4x plus 3. Now from here, if you what is the difference of both sides? If I can just do here, du squared equals d 4x plus 3. On the left-hand side, with respect to u, right, that is 2u du, that's equal to 4dx. That's one way. I don't know. Let's see what happens here. Then from this relationship, I can find x, right? What is, let me just write here. What is x? X equals u squared minus 3 over 4. This one is u squared. Okay. So now if you just write this, let's say that our integral is I. So let me change the color here. Then I is equal to integral. What is x? X is 1 over 4 u squared minus 3 times, and how about square root of 4x plus 3? That's equal to u. And how about dx? Dx is equal to, just divide both sides by 4, right? That's equal to 1 over 2 times 1 over 2 u du. So what is it? It just becomes actually a polynomial function. Here we have 1 over 4, 1 over 2, it is 8. So that's equal to 1 over 8 integral. And here we have u squared, right? U squared times u squared, u to the power of 4 minus 3u squared, and du. Which is equal to 1 over 8. Here we have 1 over 5, u to the power of 5 minus, this one is just u cubed. And here we have c. Or that's equal to 1 over 40 and u to the power of 5 minus 1 over 8 u cubed plus c. So the answer will be 1 over 40 times, actually u cubed is outside. What is u cubed? U cubed is, okay, let me just write here, 4x plus 3 squared, because it's 5, and here we have 4x plus 3. Minus 1 over 8, just 4x plus 3, 4x plus 3, 4x plus 3 times square root of 4x plus 3 and plus c. Askara, is it correct or did we make any mistake?
I don't know, sir. It's a bit complicated.
Yeah, it is not complicated, but it's a little bit long. But sometimes you will see that some integrals, they are even longer than this. What I did here is very simple thing here. First, let me just introduce u as, what is it, square root of 4x plus 3. So this 4x plus 3 under the root, it will be u. So now from this, if you just solve this equation for x, then x is equal to u squared minus 3 over 4. As I say here, I'm just trying to write everything without any roots. So now u squared equals 4x plus 3. And what is the differential of u squared? It is 2u du. And what is the differential of 4x plus 3? It is just 4 dx. So now if you divide from here both sides by 4, then here we have 1 over 2 u du, that's equal to dx. Then after that, we are just substituting everything, write everything in terms of u. At the time, we have this integral. And just simplify this, we have polynomial function because it's very easy to integrate polynomial function. Integrate this, and instead of u, write your original expression. So now I'm saying that if you differentiate the whole function here, you will get this function. Okay, and you can just test this, is it true or not? You can check it. Anyway, let's move to the next question. How about this? Evaluate the integral z dz and z squared plus 1. Again, immediately, if you look at here, for example, it says z. Actually, under the square root, we have z squared. Let me introduce this variable. U is equal to z squared plus 1. Then what is the differential of u? Differential of u is equal to differentiate this function. That is 2z, and here we have dz. That means that here instead of z dz, I can write 1 over 2 du. So now at the time, our integral becomes that integral, indefinite integral equals, instead of z dz, I will write 1 over 2 du. Over, under the root, we have cube root of z squared plus 1, that's equal to u, which is equal to 1 over 2 is a constant. Take this out, 1 over 2 integral. Here we have u to the power of cube root of u, that's equal to, what is it? Minus 1 over 3 and du. It's just a power function. We know how to integrate this. 1 over 2 times u to the power of minus 1 over 3 plus 1. That's equal to 2 over 3. And here we have 3 over 2. And here we have plus c. Or that's equal to 3 over 4 u to the power of 2 over 3 plus c. So then dot, dot, dot. Therefore, the answer is that our integral is equal to, let me just write here, I, so that I is equal to 3 over 4. What is u? U is z squared. Z squared plus 1 to the power of 2 over 3. And here we have c. That's it. Okay, using this one now, we will get a formula. The more general form, actually, we will do this later, because usually powers of trigonometric functions like sine cube, sine to the power of 4, sine to the power of 5, and 6, and 7, and 8. These are not difficult, but it's not short. We don't have any short way. Okay, the only way is we can reduce the power. Okay, and after the reducing the power, if it is 2, we can reduce it to 1. If it is 3, to 2. If it is 2, to 1. In this way, we can integrate the trigonometric functions. Okay, we don't have any, I mean, not difficult. Again, it is long, or we don't have any short way. So now let's start with the first one. Integrals of sine squared of x and cosine squared of x. Let me just do the first one on the left-hand side, the second one on the right-hand side. But actually, the derivations are similar. The first one is, let's say our function is f of x is equal to sine squared of x. So I'm just going to use one formula here, the identity. We know that cosine of 2x is equal to 1 minus sine squared of x, right? Now from here, actually here we have 2. What is sine squared of x? Sine squared of x is equal to 1 minus cosine of 2x over 2. So to integrate this function, here we have integral sine squared of x dx. I can just write here 1 over 2, right? Let me just keep 1 over 2 out. Integral 1 minus cosine of 2x. Here we have dx. So now as you see here, we don't have any function which with the power, whose power is more greater than 1. So we know how to integrate them. The first part is, it is just x. The second part is what function's derivative is cosine of 2x, that is 1 over 2 sine of 2x. And here we have c. Or just simply that's equal to 1 over 2x minus 1 over 4 sine of 2x, and here we have c. So as I say here, first I have reduced the power of sine, and after that we can differentiate this, integrate this. If it is 3, I try to reduce the power to 2, and after that again use this one. Anyway, how about the second part? The second part is, here we have g of x, that's equal to cosine squared of x. Again, I will just use this formula, cosine of 2x, that's equal to 2 times cosine squared of x plus 1. From here, what is cosine squared of x? That's equal to 1 over 2, because we are going to divide both sides by 2. And here we have cosine of 2x minus 1. So now if we need to integrate this integral of cosine squared of x dx, that is equal to integral, and let me just write 1 over 2 outside. Here we have cosine of 2x minus 1 dx, which is equal to 1 over 2. And here we have what function derivative is this? That is sine, right? 1 over 2 sine of 2x plus, not plus actually, it is minus 1. So here we have x. Now here we have constant. Or if you just remove the brackets, here we have 1 over 4 sine of 2x minus 1 over 2x plus c. Okay, if you really want to improve this, you need to practice more questions, and it's a kind of mental exercise. Let's say, okay, and sometimes spending too much time on Facebook, Instagram, or YouTube, or what is it, internet, was also boring and not so healthy. Sometimes we need to do mental exercise, so you can just practice some questions from here. That's good for your health and for your to improve your thinking skill. Okay, someday everything will make perfect sense. So for now, laugh at the confusion, smile through the tears, and keep reminding yourself that everything happens for a reason. It is yesterday's quote. After maybe 2-3 times, you will memorize this. After that, I will change this quote. Okay, now let's have break for like 15 minutes. Okay, after 15 minutes, we will continue. We have one more session and finish this week's class. See you after 15 minutes.